tutorial, we'll be talking about what? Transformers. But today we'll be talking about the introduction. We'll not go deep into what transformers are, but we'll be talking about just the introduction. What are those basic things you need to know about what? Transformer. Now, the first thing that should come to your mind is, what is a transformer? What is a transformer? So a transformer is a device that step up and step down an AC voltage source. A transformer is a device that step up or step down an AC voltage source. Now, the first thing you should note down is the step up, and the second thing is your step down. So the two paramount things which you should know is the first one is step up, while the second one is step down. What is your step up and what is your step down? The step up simply means increases, and your step down simply means decreases. So a transformer is a device that either increase or decrease an AC voltage source. What is the AC there? Alternating current. So a transformer is that device that either step up, increase, or step down, decrease an AC voltage source. Now, ask yourself, how do your microwave run, and how do your light bulb in your homes, how do they operate? Electricity is being generated through the power station, sent towards our step-up transformer that increases the voltage to a maximum amount of voltage. Now, that maximum amount of voltage is being sent across through transmission lines down to our communities, where we have the step-down transformers. Now, the step-down transformers reduces the voltage to 230 volt sockets. So those transformers reduces the voltage to 230 volts. Now, this 230 volts is being sent across to our homes, where we see the electricity. Now, I'm asking you, how do your microwave operate? How do your microwave operate? And why do you charge your phones with this 230 volt source? Is it not too high for your phones, and is it not too low for the microwave? That is where your transformer comes into play also. Your transformer for your microwave that needs a maximum amount of voltage. Let's say you have a microwave that requires 2000 volts to operate. You have a microwave that requires 2000 volts to operate, and you have your light bulbs. You have your light bulbs that requires maybe 2 volts or 4 volts to operate. I'm taking this as an instance, as an example. Now, if you have this microwave that requires 2000 volts to operate, and you have your light bulbs that requires smaller amount of voltage to operate, and you have a 230 volts source here, how do your microwave now run? That is the help of your transformer. So now, when you plug this directly to your microwave, it won't work. If you plug your 230 volt source to your microwave, it won't work, because it requires this 2000 volts to operate, or a voltage that is more than 2000 to operate. But here you are having a 230 volt. That is where your transformer comes into play. So your transformer helps to step up this voltage to this required amount of volts that your microwave needs. So what you have here, you simply have your step up transformer. Now, the step up transformer simply increases your voltage here to this amount of voltage, and your 230 volt supply, if you connect it directly to your light bulb, it's going to burn. Why? Because it requires a minimum amount of voltage, or a small amount of voltage, like 2 volt or 4 volts. But here you are having a 230 volt. So your transformer here comes into play by by stepping down, or reducing this 230 volts to this one here. You understand? So your transformer comes into play. For your microwave, it increases the voltage here for your light bulbs or your cell phones, it reduces what the voltage to this required amount of voltage that your light bulb or your cell phones need. The transformer, I told you the transformer is a device that step up and step down an AC voltage source. Now your transformer basically consists of two coils. Your transformer basically consists of two coils. Now the first coil is what we call the primary coils. The first one is what we call the primary coils, while the second one is what we call the secondary coils. So I told you your transformer consists basically of what? Two coils, the primary coil and the secondary coil. Now these coils are also called windings. Windings. So if you are not seeing coils, you'll be seeing what? Primary windings. And you also be seeing what? Secondary windings. So your transformer consists basically of what? Your primary windings and your secondary windings. Now take this down. The primary windings are those windings connected to your AC source. The primary windings are those windings or coils connected to your AC source. While your secondary windings or your secondary coils are those coils connected to your load. So your primary windings are those ones connected to your AC source, while your secondary, they are those coils connected to your load. Let's take this transformer as a case study. Let's say we have a transformer of this nature. This is a transformer. Now this is a transformer. I told you one side is connected to to the load, while the other one is connected to an AC source. So how do you identify your primary winding and your secondary winding? I told you your primary coils or your primary windings, they are those sides connected to your AC source, while the secondary, they are those windings connected to your load. So you can see that this transformer, this part is connected to your AC source, and this part is connected to your load. So how do you identify the primary and secondary? Now the primary side of your transformer is this side. So this is your primary, and this is your secondary. Why is this your secondary? Because it is connected to to the load. That is why it is the secondary. And this side is connected to your AC source, which is your primary. So we talked about a transformer being a device that step up or step down an AC voltage source. Now, how do you identify a transformer that step up and a transformer that step down an AC voltage source? Now, you identify this through your coils or through your windings. Through your coils or through your windings. Now, for you to identify a step-down transformer, look at your windings. If your primary side of your transformer is greater than this secondary side of this transformer, then that is a step-down transformer. But in a case where your secondary is greater than your primary, then it is a step-up transformer. Now, let's take this. Let's talk about the step-down. Step down. Now I told you, if you look at your transformer, if you see that your primary side is greater than your secondary side, then it is a step down transformer. So if you take a transformer of this nature, and you know that this side of the transformer is connected to your load, and this side is connected to your AC source. Now, how do you identify this transformer to be a step down? Look at this side of the transformer, look at the windings. Now you can see that the windings is greater than this secondary winding. So in a case where your primary windings or your primary coils are greater than your secondary coil, then that is a step down transformer. Now what if a case where you have this? and you have this also. We know that this is connected to our load, while this is connected to the AC source. How do you identify this to be your step-up transformer? Now look at this and look at this. You can see that there is a difference. In this one, you have your windings here greater. You have your windings here less than the secondary. So in a case where you have your primary windings smaller than your secondary windings, or your secondary windings greater than your primary windings, then this is a step-up transformer. So you have been able to identify your primary side of your transformer and the secondary side of the transformer, and you've also been able to identify a step-down transformer and a step-up transformer.